Example number 1, let T is a mapping from R cube to R cube defined as T of xyz is equal to e raised to x, e raised to y, 0. Check whether T is linear transformation. We can say that if T is a mapping from V to W, say if T is a mapping from V to W is linear transformation, then T is said to be a linear transformation if first it satisfies T of u bar plus V bar is equal to T of u bar plus T of V bar, and L2 T of ku bar is equal to k times T of u bar, where u bar and V bar are vectors from vector space V. Now given T is a mapping from R cube to R cube, first we consider vector u bar is equal to say x1, y1, z1, and V bar is equal to x2, y2, z2. Then u bar plus V bar, where u bar and V bar are vectors from R cube in vector space R cube. Then u bar plus V bar is equal to x1 plus x2, it is x1 plus x2, y1 plus y2, and z1 plus z2. Now if you apply the T on both sides, we get T of u bar plus V bar is equal to T of x1 plus x2, y1 plus y2, and z1 plus z2. Now the given map is defined as T of xyz is equal to e raised to x, e raised to y, 0. So this become e raised to x1 plus x2, e raised to y1 plus y2, and 0. If you simplify this is nothing but the e raised to x1 into e raised to x2, e raised to y1 into e raised to y2, okay, 0. Now this is the right hand side. See, this is RHS, or equation number 1. This is nothing but the T of u bar plus V bar. Now consider left hand side, say LHS, this is RHS, okay. So LHS is equal to T of u bar plus T of V bar. So here T of u bar is equal to T of x1, y1, z1 plus T of x2, y2, z2. So this is equal to, now T of x1, y1, z1 is equal to e raised to x1, e raised to y1, 0, and t as to x2, y2, z2 is e raised to x2, e raised to y2, 0. Now if you add these two vectors, we get e raised to x1 plus e raised to x2, e raised to y1 plus e raised to y2, and 0 plus 0 is 0. So this is nothing but the T of u bar plus T of V bar. Now from this equation number 1 and 2, what we can say that here, now since e of x1, x2 is not equal to, since e raised to x1, e raised to x2 is not equal to e raised to x1 plus e raised to x2, and therefore from this, from 1 and 2, so this is equation number 2. I am writing equation number 2, okay. So if you compare these two equation number 1 and equation number 2, what we can observe here that T of u bar plus V bar is not equal to T of u bar plus T of V bar. Okay, so T is not a linear transformation. So therefore T, the given map T is not a linear transformation. Example number 2. example number 2. Let T is a mapping from R cube to R square, given as T of x, y, z is equal to x plus y plus twice z, x plus z, and twice x plus y plus thrice z, Find basis for kernel of T and arrange. Find basis for kernel and arrange of the linear transformation T. Okay, so the map is given T of x, y, z equal to, I am writing here again, T of x, y, z is a linear transformation and is given as x plus y plus twice z, then x plus z and twice x plus y plus thrice z. So the first want to write this linear transformation as T of x is equal to x in a matrix form. So if we write this as in a matrix form, we get T of x, y, z is equal to 1 1 2 1 0 1 2 1 3 into x, y, z is there. So the first we want to determine basis for that is kernel. First we want to determine basis for kernel, and it is nothing but the basis of kernel is same as basis for null space of A. This is for null space of A. Now to find a null space of A, we consider homogeneous system x is equal to 0. So x is equal to 0. If we consider x is equal to 0, we get here 1 1 2 1 0 1 and 2 1 3 into x, y, z equal to 0 0 0. So now to solve this homogeneous system, we want to reduce this matrix to row echelon form by using row operations. So it is R2 minus R1 and R3 minus 2 times R1. So if you use this row operation, we get 1 1 2, then 1 minus 1 0, 0 minus 1 is minus 1, minus 1 minus 2 it is minus 1, 2 minus 2 0, 1 minus 2 minus 1, 3 minus 4 minus 1 into x, y, z equal to 0 0 0. Now multiply the second row by minus sign, we get it is equal to 1 1 2 0 1 1 0 minus 1 minus 1. And now finally if we we use a row operation, R3 is equal to R3 plus R2, we get a matrix is 1 1 2 0 1 1 0 0 0. Now this matrix is in row echelon form. So now if we reduce again, if you convert this matrix to system form, we get, before that we want to determine how many leading variables and free variable. Here leading variables are, now this is the leading variable of x, this is the leading variable of y, so x and y are leading variables, and free variables are z. So now if we consider this into a system form, we get x plus y plus twice z is equal to 0, y plus z is equal to 0, and since z is a free variable, so put z is equal to t. This implies y is equal to minus t, and from this we get x is equal to since z is a t, if we substitute this value here, we get y is equal to minus t, and if we substitute z and y in first equation, if you substitute these two value in this equation, okay, then we get x plus y, so minus t plus 2t equal to 0. This implies x is equal to minus t. So here the null space, that is, what is here null space of A? So the null space of A is equal to x y z, that is minus t t, where t belongs to R. T is what? A real number. I am writing here t also belongs to R. So this is nothing but A is equal to null space of A is equal to minus 1 1 into t. T belongs to R, so it is spanned by minus 1 1. So this what is this subspace is spanned by this vector minus 1 1, and therefore what is the basis for null space? For null space, which is same as space of A, which is same as basis for kernel of t, which is equal to minus 1 1. Okay, so now therefore the what is here nullity? From this we can say that the nullity, the question is only to determine the basis, but what is dimension here? Dimension is 1, or it is also called nullity. So now you can use a maxima also to find the null space of A. For that you have to enter your matrix in a maxima first. So to enter a matrix, just write down A is equal to the matrix, the first row is 1 1 2, then 1 1 2. The second row is 1 0 1 1 0 1, and the third row is 2 1 3 2 1 3. So now this is the matrix A. To find a null space of A, just enter the command null space of A, and null space of A, null span 0, null space of A. Just 1 minute. Here the matrix is incorrect. It is what? 1 1 2 1 0 1. So here I want to write 1 0 1 1 0 1, and now if you write here null space of A, then it is what? It is spanned. You can check here, it is spanned by the vector minus 1 1 1. You can check here, it is what? It is spanned by minus 1 1 1. So what is the basis for null space of A, which is same as basis for kernel of T? It is what? minus 1 1 1. Similarly, now next we want to determine basis for range space of T. So now the next step, just star and write star basis for range space of T. Now which is same as basis for column space of A, column space of A. So now what is the column space of A? This just column vectors corresponding to leading one form a basis for column space of A. Now here leading one is present in first row column, and leading one present in second column. So the original column vectors form a basis for column space of A. So it is 1 1 2 and 1 0 1. So what is the basis for column space of A? It is 1 1 2. I am writing here basis for range of T, or range space of T is equal to, what is it? Is 1 1 1 2 and 1 0 1 1 1 2 and 1 0 1. These are the basis for a range space of T. Now you can use a maxima also. Now already we have entered here matrix A. Okay, and we determine null space of A. Now if you write here column space of A, you can check here 101 and 112, and here you can check we get the same 112 and 101. Here also we can check it is what same as 101 and 112. So this way you can find a basis for kernel of T and a basis for range of T, where T is a linear transformation. Now the next example, this is a second example. Now the third example is, let T is T1 is a mapping from T1 is given as T1, T2, T3 is given as a linear transformation. I am writing let T1 xyz xy T1 xy is equal to x plus y plus y, x plus y, y, and minus x. Third example, T2 of xyz is equal to 0 x plus y plus z thrice y, and T3 of xyz is equal to thrice x minus twice y twice y, and 4z minus x minus thrice y. And question is find domain and codomain for T3 of T2 of T1, and also find the formula for T3 of T2 of T1 xy. T3 of T1. Now first of all, from this what we can observe here that T1 is a mapping from R square to R cube, T2 is a mapping from R cube to R cube, and T3 is mapping from R cube to R square. So what is T3 of T2 of T1? It is a mapping from R square to R square. Okay, now why it is possible? Because the codomain of T1 is domain of T2, codomain of T2 is domain of T3, and therefore T3 of T2 of T1 is a mapping from T3 of T2 of T1 is a mapping from R square to R square. So here this implies domain is R square and range is also R square. Now next we want to determine the formula for T3 of T2 of T1. So the T3 of T2 of T1 xy, since it is a mapping from R square to R square, this is nothing but the T3 of T2 of T1 xy. So what is T1 xy? The T1 xy is equal to x plus y, y minus x. This is nothing but of T2 of x plus y minus y x. I am checking once again, x plus y, y minus x. Sorry, here it is y minus x. Okay, y minus x. So now T3 of T2 of T3 of T2 is T2 of x plus y, y and minus x. So what is T2 of xyz? I am writing the formula for xyz is equal to the T2 is 0 x plus y plus z 3y, 0 x plus y plus z and thrice y, x plus y plus z and thrice y. If you apply this formula here, in place of x it is x plus y, in place of y is y, and in place of z it is minus x. So if you apply this formula here, okay, I'm writing this in bracket, so you get the T3 of, so what is the formula? First is 0, then add these three coordinates, so it is x plus y minus x and thrice y, so it is same as thrice y. Okay, so if you simplify this, it is equal to T3 of 0 twice x get cancelled here, twice y thrice y. But what is the formula for T3? So the formula for T3 xyz is thrice x minus twice y. I am writing here T3 of xyz. I am going to use a different color here. So what is a T3? T3 of xyz is equal to, the formula is what? Thrice x minus twice y, thrice x minus twice y, and 4z minus x minus thrice y, 4z minus x minus thrice y. I am checking one again, 4z minus x minus thrice y, here not x, it is z, 4z minus x minus thrice y. So if you use in place of now in this transformation, in place of x it is 0, okay, in place of twice y it is y, and in place of z it is what? In place of y it is twice y, in place of z is thrice y. So this is equal to, sorry, this is equal to it is equal to thrice x, so it is 3 times 0 minus 2 twice y, so it is in place of y it is twice y, 4z, so it is thrice y, minus x, so it is 0 minus thrice y, so it is twice y. So if you simplify this, it is equal to minus 4y, then 12y minus 12y minus 6y. So this is nothing but the minus 4y and 12y minus 6y, it is nothing but again 6y. So this is the formula for T3 of T2 of T1 xy. So what is the formula here? Minus 4y 6y. Okay, now next, similarly you can try it for T1 of T2 of T3. Okay, now the next example number say 4, example number 4. Let T is a mapping from R square to R square be a multiplication of matrix. Let T is a mapping from R square to R square be a multiplication of matrix, be a multiplication by matrix A. Determine whether T has an inverse. Determine whether T has an inverse and find a formula for T. Okay, now where T of x, the given is A is equal to 1 1, in formula for T inverse, not T 1 1 1 0. Okay, and we want to determine T inverse of x1 x2. So the given T is a mapping from R square to R square be a multiplication by matrix A. That is here T of x is equal to AX. So here the given transformation is T of x is equal to 1 1 1 0 into XA XY. So this is nothing but the x plus y. This transformation is say x plus y and x. So T of xy is equal to x plus y x. Now I want to check whether T is a linear transform, whether T has an inverse. So the first step, we want to check whether T is 1 1. T is injective, or in other word, whether T is 1 1. That is T is 1 1. So what is the condition? We want to check where kernel of T is 0. If kernel of T is 0, then T is 1 1. So for that, consider T of xy is equal to 0 bar, that is 0 0. So this is implies x plus y, x is equal to 0 0. If you equate the LHS and RHS, we get x plus y equal to 0 and x is equal to 0. From this, what we get, x is 0 and y is also 0, and therefore kernel of t is equal to 0 0, and which is nothing but the 0 bar. Okay, and therefore this implies T is 1 1 or injective. Now step number 2, we want to check whether T is surjective, that is T is onto. For that, consider, suppose let x1 x2, say x1 x2 x1 x2 belongs to R square, be any vector such that T of xy, say T of xy is equal to x1 x2. We want to determine x and y in terms of x1 x2. So what is T of xy here? T of xy is equal to given as ax. So what is ax here? X plus y x. This is nothing but the x plus y x. So is equal to x1 x2. Now if you compare the LHS, equate the LHS and RHS, we get x plus y is equal to x1 and x is equal to x2. So from this we get the value of y is equal to x1 minus x2. So here the T of this x is what? X is x2 and y is x1 minus x2. So x2 and x1 minus x2 map to x1 x2 for any x1 x2 in R square. So for every element in every vectoring codomain has a at least one pre-image, and therefore T is surjective. In other words, T is 1 onto, and therefore T has an inverse. Now since step number 3, T is 1 1 and onto, and therefore T has an inverse. And what is the formula for? From this we get the formula, since T of x2 and x1 minus x2 is equal to x1 x2, and therefore T inverse of x1 x2 is equal to T inverse of x1 x2 is equal to x2 and x1 minus x2. So this is the formula for T inverse of x1 x2. Now the last example number 5. Let given T is a mapping from R cube to R cube, given as T is a mapping from R cube to R cube, be a linear transformation, and defined as T of x y z is equal to twice x plus y minus z thrice x minus twice y. Sorry, it is thrice x minus twice y plus 4z. It is a mapping from R cube to R square. Okay, and find a matrix A. Now here I want to find a matrix A of T with respect to of t with respect to a basis of b1 which is equal to 1 1 1 1 1 1 0 1 0 and 1 0 0 0 0, and the basis for b2 are 1 3 1 4 1 3 1 4 of r cube and r square respectively. These are the basis for r cube and r square respectively. So now, so as we know that if t is a linear transformation, say t is a linear transformation, t is a linear transformation, and v1, say b is equal to v1 is equal to say v1 v2 bar, say vn bar are basis for b1, and b2 is equal to w1 bar w2 bar dot 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 wn bar basis for b2, and t is a mapping from then since t is a linear transformation, then we can write t of v1 bar is equal to a11 w1 bar plus a12 w2 bar plus dot 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 a1n, say a1n wn bar. Similarly t of vn bar, say t of vn bar can be written as a11 w1 bar plus a12 w2 bar plus dot 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 an1, say here an1 a1 n1 an2 an wn bar, maybe we use here n instead of n, if we use here yum, since the dimension may be different. So wm bar a1 yum wm bar, then an yum wn bar. So now this then what is the matrix of t with respect to basis b1 and b2 is equal to a11 an1 a12 an1, then a1m to a1n to anm. So now given these are the basis for r cube and b2 are the basis for r square. So what we want to determine here, first we want to determine what is the image of t of 1 1 1. So the image of t of 1 1 1 is, so t of 1 1 1. Now what is given t of xyz? Since t of xyz is equal to, I am writing here formula for t of xyz, it is twice x plus y minus z, twice x plus y minus z. And what is the formula for thrice x minus twice y, thrice x minus twice y plus 4z. So the image of t of 1 1 1 is equal to 2 plus 1 minus 1 and 3 minus 2 plus 4, and therefore t of 1 1 1 is equal to 2 plus 1 is 3, so it is 3 minus 1, it is 2, and 3 plus 4 7 minus 2 is equal to what, 5. Now we want to express this we want to write this t of what the first element, that is 2 5, into a linear combination. Now this 2 5 lie in this vector lies in r square, but the basis of r square is what, b2. So we want to write this vector 2 5 in the linear combination of 1 3 and 1 5. For that we consider 2 5 is equal to alpha 1 times what, alpha 1 times what is the first basis given, 1 3 and 1 4. so 1 3 and alpha 2 times 1 4. So if you simplify this, we get 2 5 is equal to alpha 1 plus alpha 2 and 3 alpha 1 plus 4 alpha 2. So if you simplify this, we get alpha 1 plus alpha 2 is equal to 2 and 3 alpha 1 plus 4 alpha 2 is equal to 5. Again, if you simplify it further, as then 3 alpha 1 plus 3 alpha 2 is equal to 6. We multiply the first equation by 3 and the second equation as it is equal to 5. Now if you subtract these two equations, we get what we get. This 3 alpha 1 get cancelled here, minus alpha 2 is equal to 1 and therefore alpha 2 is equal to minus 1 and alpha 1 is equal to, if you substitute this value any one of these equation, we get alpha 1 is equal to 3. So the first we get here 3 minus 1. What is alpha 1 alpha 2 here? Alpha 1 alpha 2 is equal to 3 minus 1. So this is the first column of the matrix T with respect to basis B1 and B2. Similarly, we want to determine the image of T of 1 1 0. So what is the image of T of 1 1 0? So T of 1 1 0 is equal to, what is the mapping given? Map given twice x plus y minus z, twice x plus y. So twice x plus y minus z, y is 1 minus 0. And the next is what? Thrice x minus twice y, thrice x minus twice y plus 4z. So it is what? Z is 0. So this is nothing but the 2 plus 1 is 3, 3 minus 2 is what? 1. So now I want to write this 3 1 into again a linear combination of this 1 3 and 1 4. So 3 1 is equal to, then we get an equation as alpha 1 plus alpha 2 is equal to, we get the new equation alpha 1 plus alpha 2 is equal to 3 and alpha 3 alpha 1 plus 4 alpha 2 is equal to 1 from this previous equation. In place of 2 and 5, just we write here 3 and 1. So again, if you simplify this, we get 3 alpha 1 plus 3 alpha 2 is equal to 9 and 3 alpha 1 plus 4 alpha 2 is equal to 1. Now this will get cancelled here and minus alpha 2 is equal to here 8 and therefore alpha 2 is equal to minus 8. If you substitute this value any one of these equation, then we get alpha 1 is equal to what? 11. So the new next column for the matrix T is alpha 1 alpha 2 is equal to 11 minus 8. Similarly, now the last want to find the image of the basis vector 1 0 0 under which transformation? Under this transformation 2x plus y minus z, 3x minus 2 is twice y plus 4z. So the T of 1 0 0 is equal to, what is the first? The mapping is given is twice x plus y minus z. So y and z are 0, so twice x, so it is 2. And the third, the second quantity is thrice x minus twice y plus 4z. So thrice x, so it is equal to 3. Now this vector 2 3 lie in the codomain vector space, that is R square, but the basis of R square is given 1 3 and 1 4. So we want to express this 2 3 in the linear combination of 1 3 and 1 4. So again we get the same equation alpha 1 plus alpha 2, we get the same equation alpha 1 plus alpha 2 is equal to 2 and 3 alpha 1 plus 4 alpha 2 is equal to 3. Instead of here, you can check here I am changing, highlighting here, you can check here. Okay, instead of 3 and 1 I am writing here 2 and 3. Okay, so therefore again if you solve this, we get, if you multiply the first equation 3 by, then we get 3 alpha 1 plus 3 alpha 2 is equal to 6 and 3 alpha 1 plus 4 alpha 2 is equal to 3. So if you subtract these two equations, then we get minus alpha 2 is equal to 3 and therefore alpha 2 is equal to minus 3. Now alpha 2 is minus 3, implies alpha 1 is 5, 1 is 5, and therefore what is the coordinate vector here? 5 minus 3, sorry, here the last the alpha 1 alpha 2 is equal to 5 minus 3. So the now we want to form a matrix with respect to basis b1 and b2. So the matrix with respect to basis b1 and b2 is equal to, it contain column vector of column vector coordinates of image vector. So what is the first? We get 3 minus 1, alpha 1 alpha 2 is what? 3 minus 1. So the first column is 3 minus 1. The second one is what? 11 minus 8, 11 minus 8, and the third one is 5 minus 3, 5 minus 3. So this is the matrix of T with respect to basis b1 and b2, and we use this matrix for transformation, further transformation. Okay, so it's a lots of application further. So we are going to stop here for this lecture.